Today, we're diving into some fascinating new research that totally flips a common assumption about AI right on its head. I know it sounds completely backwards, right? We're always pushing for faster processors, bigger models, more power. But what if the secret to a more efficient and maybe even a more human like AI isn't about constant computation, but about knowing when to just take a break? To really get why thinking less could be a superpower, we first need to talk about a pretty common problem in AI and robotics. Let's call it the overthinking robot problem. Think about how you reach for a coffee cup. You don't consciously calculate the exact trajectory for every single millisecond of the movement, right? You just start a general, good enough motion and make tiny little corrections along the way. Classic AI, on the other hand, often gets stuck in this crazy loop of constant, nonstop replanning. It's recalculating its entire path at every single step. It's totally exhaustive and computationally very, very expensive. And look, this isn't just some theoretical thing. As the researchers behind today's paper point out, this computational cost is a major practical hurdle. It's holding back the development of more advanced, more autonomous AI. So where did they look for a better way? Well, they looked to the most efficient control systems we know of, biological ones. I mean, nature figured out how to be smart without wasting energy millions of years ago. And this led the researchers to two really key concepts. The first piece of the puzzle is active inference, or AIF. Now, this is a big framework, but the core idea is that intelligent beings, like us, are constantly trying to minimize surprise. We try to reduce the difference between what we expect to happen and what actually happens. We act to make our predictions about the world come true. And the second ingredient is intermittent control. This is that idea we just talked about with the coffee cup. Human motor control isn't this continuous, perfectly smooth process. It's much more like a series of quick, fire-and-forget movements, with corrections happening in little bursts only when they're really needed. It's like we have a built-in on-off switch for our attention and control. So, what happens when you combine the why of active inference with the how of intermittent control? Well, you get the star of this explainer, a much smarter switch. This is intermittent active inference, or IAIF. Now, instead of planning nonstop, an IAIF agent makes a plan and just sticks to it. It only stops to think and create a new plan when something specific happens, a trigger. So the crucial point here is it's not just thinking less, it's deciding when to think. So how does it decide? The researchers came up with two really clever triggers. The first is belief divergence. This basically means the AI replans when what it's seen diverges too much from what it predicted would happen. In simple terms, it's the AI going, whoa, the world isn't behaving like I thought it would. Time for a new plan. The second trigger is a bit more sophisticated, the expected free energy, or EFE error trigger. Okay, think of it like this. You pick a route on your map app that looks great. But halfway there, you see a huge, unexpected traffic jam up ahead. You realize the future of this route is much worse than you initially thought. That's the EFE trigger. It's the AI realizing its current plan is leading to a worse outcome than it first predicted, prompting it to say, yeah, let's find a better way. Okay, this all sounds great in theory, but does it actually work? Well, the researchers put this new AI to the test in a simple but really elegant experiment. They used a classic human-computer interaction task, moving a mouse cursor to a target on a screen. It's a simple, measurable task that involves all the key ingredients: planning, action, and reaction. And they pitted their new intermittent AIF agent against a classic, constantly planning AIF agent. Now, what's so cool about this is you can see the AIF agent in action. The smooth parts of that blue line show the agent just cruising along following its plan. And those little black markers at the top, that's the EFE trigger firing. That's every single time the agent decided, okay, time to stop and think again. You can see it thinks a lot as it's getting close to the target, but then it just chills out once it's there. And this brilliantly illustrates the most surprising result. On the left is the movement pattern of the classic, constantly thinking AI. On the right is the intermittent AI. See that extra little bump in the trajectory on the right? That's a submovement. It's a small corrective action. And it's a classic signature of how real humans perform these tasks. So by thinking less, the AI actually started to behave more like a person. How wild is that? So it's more of human-like, which is cool. But what about the bottom line? Did all this not thinking hurt its performance? Let's look at the data. And the results are stark. The classic agent, by definition, replanned at every single one of the 100-time steps. But the IFGearY IFA agent with that smart EFI trigger? On average, it only initiated a new plan about 64 times. That's a reduction of nearly 36%. That is a massive saving in computational load. It means the AI is doing significantly less work. But here's the kicker. The crucial point is that this huge efficiency gain came with no statistically significant drop in performance. The INAF agent was just as good at the task, it just accomplished it using far less brain power. In a way, it was smarter by being lazier. So why does all this matter? Why is a more efficient mouse pointer a potential game changer for the future of AI? Let's zoom out to the big picture. The benefits of this approach are huge, and they go far beyond moving a cursor. First, there's pure efficiency. Imagine powerful AI that doesn't need a supercomputer, but can run on your phone or a small delivery drone. Second, there's realism. By mimicking our own intermittent control, we can build robots that move and react in ways that feel natural and predictable to us. And finally, this is a major step toward resource-aware AI, agents that understand they have a limited computational budget, a vital skill for any AI operating in the messy, unpredictable real world. So this leaves us with a fascinating final thought. We've been in a race to build AI that thinks faster and harder. But maybe the real breakthrough will come from building AI that has the wisdom to know when it's better to just stick with the plan and not to think at all.